Good morning to all. I am Professor Sandeep Aher as a lecturer Sandeep Polytechnic, Sandeep Foundation, Nasik. So friends, very warm welcome to this online lecture series, that course Advanced Manufacturing Process, chapter number 4, Fundamental of Computer Aided Manufacturing, lecture number 15 under the chapter, that is lecture number 3rd. So we are going to see that tool presetting. So before this, I'd like to revise in previous lecture what we learned, that is the what exactly NC, CNC, DNC, its application, advantage, disadvantage, and at the last its classification, its basic components, its devices, feedback sensors. Likewise, we are going to see here tool presetting. So in CNC machine, tool presetting for the every machine, it is not required compulsory, but sometimes in each operation is used different tools, so that different tools, that standards are different, their sizes are different, so there need to tool presetting for each machine. So most of CNC machines have no built-in tool measurement mechanism. So to measure CNC machine tool, external tool measuring devices are used. So pre tool presetting means before this operation that setup is required, that is a tool presetting. These tool measuring devices are called tool presetter mechanism. A CNC tool presetter is highly accurate device which is used to measure CNC machine tool. As the machining is carried out by the tool tip, it is important to know exact dimension of tool when it is placed in the spindle, because consider that the size of that tool to measure these further parameters, or for part programming purpose we have put same parameter. So when consider that the same parameters put in while during the operation, so some error may be find out in this tool presetting, so that may directly affect on this operation of this workpiece. So it therefore becomes necessary to know precisely the deviation of tool tip from the gauge point on the spindle. Hence, tool setting equipment is generally used. So this is a block diagram here showing here what is the tool presetter: micrometer, tool, adapter, spindle, taper. There should be standard equipments to measure the exact tool size or maintain the gap of that tool spindle speed to the base of the workpiece. Now 3D diagram I am also showing here for the tool presetting, means it is to maintain the standard for the coordinate system for the further operations. Now we are going to see next, qualified tool. So what exactly qualified tool? The tool which fits into a location on the machine where its cutting edge is accurately positioned within closed limit relative to a specified datum on the tool holder or slide is known as qualified tool, because as per the standard different tool sizes are also there. So there may be says to not exactly touch to the datum of tool holder, so qualified tool holder are there, so it provide certain range of the tolerance that can be permit for this operation. So similarly in qualified tool, the cutting tool or edge is maintained at a fixed distance within a tolerance The total variation is given in unidirectional plus bidirectional, that is plus minus 0.05 with respect to reference surface of the holder. Here observe that tool 1, tool 2, tool 3, that datum later, that range is given 0.05, that is the tolerance. So that's why qualified tools are the tools on which position of the cutting edge is guaranteed within close limit of accuracy from a specified datum on the tool holder. The qualified dimension are applied to the tool tip from the three datums. Usually datums in the surface are formed by the tool holder. So the dimension of tool holder are fixed and known for the precise position of tool tip. It is known and accurate positioning on the machine tool is possible. That's why showing here, this is the block diagram, three tools, but you have to maintain that tolerance to respective bottom. So that is the qualified tool. Now advantages of this qualified tool. So no presetting device is used, so that investment is less because that tolerance zone is given. That's why no presetting is required. The tool need not be measured individually. There is no need to measure individually because that tolerance zone is given. So setup time is reduced as detailed planning as in tool presetting is not needed. So there is no need of trial cuts before taking rough cuts because there is a standard range is given. So obviously that operation will be 100% correct. So there is no need to take rough cut. So programming is easy with respect to qualified tool. So that programming should be easy with respect to that qualified tool because that manual operated some part may be changed, so we can measure or in trial and error method we can done this program. So there may be chances of directly effect on the workpiece, so avoid that purpose. We get exact correct value on the same program, so that's why qualified tool is used. Now types of tool holders. There is again one of the concept related to the CNC machine. Now here you observe single point cutting tools are there, and then single point cutting tools in which there insert, no insert, it is the only that point have to cutting edge is provided. So similarly the tool holder is a machining component that holds the cutting tool in place, that cutting edge, cutting corner. It is purpose is to hold the tool in place as precisely and firmly as possible because the tool is very important because tool is directly contact with the workpiece. So when tool may be deflect some dimension or vibration may occur on directly workpiece, so avoid that purpose tool is firmly fixed so that cutting force or vibration or will not run out or break the cutting tool. It is essential that insert means this golden color parts, this is called as an insert. Under this Allen key you have to fix here, and this is the tool holder, again firmly fixed. So that's why insert be supported a strong rigid manner to minimize the deflection and possible vibration. So turning tool holder, there is a range of choices for turning tool body. It depends upon the type of operation done by the insert. For a specific tool holder is given here, because that material, that black color material is different. It is not important that material, it's only support base, but this golden color materials is very important as operation point of view. So this is called as insert, and inserts having different shape. These are the square insert, this is a triangular insert, this is exact triangular insert. So these four edges we can use after one edge is wear out. So here three edges are given. So their material may be carbide, tungsten, yeah, diamond also. The ancient numbering system, standard numbering system for turning tool holders has assigned letters to specific geometries in term of lead angle and end cutting edge angle, because this is a single point cutting tool insert also there. So there is a common terminology: rack angle, it may be positive, negative, back rack angle, cutting edge angle, clearance angle, likewise, because as specific function point of view. So machining operations of turning, facing, growing, threading and cut off are covered by one of the seven basic tools style outlined by this system. So these are the types of tool holders are required. Now collets, you already aware about that collets. Have you observed that object in, I think, drilling machine? So in the spindle to pivot the cutting tool or fix the cutting drill bit here. So that purpose this part is known as collet. So milling cutter, drills on lathe and other straight shank cutting tool are usually held in place, that is called as collet. The two principal types of collets are spring collet and solid collet. So spring operated also and solid collet also. So solid collet, so these are the four slots are given here. You observe here three slots are there to hold the cutting tool. The hold the cutting tool to place solid collet are connected and to driven by spindle through drive key. So one of the key is also provided, that is locking here, and to rotate this circular teeth like spiral teeth are given, then lock this drill bit, and when it rotate in anti-clockwise again it release the dimension, so thus to remove the tool. So that is a simple thing, means tool holder can be extended with adapter place, like nothing but this adapter on the nose of tool holder. Straight shank tools are usually mounted in the collet which has jaws. So these are the three jaws that clamp the sides of the tool to align it and hold it in place. So adjustable collets are also available with the internal jaw that are tightened on the tool shank using a key that acts as a gear to turn the locking mechanism, that is the gear used for to locking and unlocking for this collet. So that is a simple. Now you have to write again application. So it is used in drilling machine also there, and in number of machines are there, but you have to write specific application. Now next topics we'll discuss, that is the machining center. So what exactly machining centers are there? So how to calculate that center? So in machining, that tool always moves in position to the coordinate axis in x, y and z. So in lathe machine only two axes, that is x and z, and z is always a rotary action or spindle driving axis. Now in milling there is also x and y, sometimes z also there, drilling operations also there. So in lathe machine only two axes, so that's why it is called as a two axis machine. Each machine tool, regardless how well it is automated, is designed to perform basically one type of operation. But in manufacturing operation, most part required number of different cutting operation on their various surfaces. Was for example, consider a diesel engine block. All surfaces of the engine block require different machining operations such as facing, milling, drilling, boring. Likewise, additional way to perform this operation by moving the part from one considerable time to moving part one machine to another machine, clamping them and removing them, so that machine table require the machining center. So capability of CNC machine have also been enhanced by addition of automatic tool changer, tool magazine, thus making them versatile. The CNC milling with such capabilities is called as machining center. A machining center is the computer controlled machine tool with automatic tool changing capability. The machining center is designed to perform a variety of cutting operations on the different surfaces of that workpiece. So that's why we need that the machining center. Now, what that exactly need of machining center? Sometimes question may be there. What is the need of machining center? To reduce the non-productive time and thereby to reduce the lead time. Means whatever dwell time from one operation to another operation, that should be reduced. To increase the productivity, to increase the production, to reduce the work in process. So whatever process that can be reduced, because saving the time to measuring the coordinates on the respective surface also. Obtain a versatile machine capable of performing different operations and thereby finish the need of variety of the machine tools. To reduce the floor space area significantly, to reduce the number of skilled operator and the problems associated with them. It requires skilled operator also. So that's why it is the need of machining center. Now, characteristics of machining center. So these are versatile machine capable changeover from one type of product to another, so that can be accessible. The time required for loading and unloading of the workpiece is reduced due to automatic pallet changer. The time required for loading and unloading, similarly cutting tool is reduced due to use of ATC, that is automatic tool changer. And these are the two different functions, APC and ATC. So they are capable of folding efficiently the parts of various shapes and sizes. They can repeatedly produce a high dimensional accuracy. So we get exact dimensional accuracy. A machining center operator can handle two or more machines at the same time. So faster cutting speed and heavier cutting depth and feed can be obtained. Means it easily control the cutting parameters. So advantages: it increase the productivity. Ultimately, it can machine to much close tolerance to get exact tolerance value. Less floor time between operation, reduce the inventory, again that is very important. Less chance of error as it eliminates the use of number of machines. Now, types of machining center. It's very simple parts. Horizontal machining center, vertical machining center, and universal machining center. Under this center is horizontal, so that's why it is called as horizontal machining center. There is the center position is vertical way, so that is a vertical center. Now both attachment is given, vertical also horizontal, that is the universal machining center. And any machine component, so these are the same functions, and I think same machine like drill machine, lathe machine or milling machine, so likewise similar components are there. So machining center has withstand heavy cutting forces and to provide accurate performance for long duration. So common components, sometimes question may be that to explain the machining center as horizontal, vertical or universal with its basic components. So student have to write first common part, that is the bed, and always write the bed function to support the all mountings, and it is made up of heavy cast iron. Saddle, it is mounted over the guideways on the bed, it carries the column over it, and saddle is for the sliding purpose, avoid the friction purpose, that recirculating bearings are used in x-axis movement. Then column is a vertical, that's why this is a y-axis, provide this sliding moment. Then table or column, it is also called as vertical member to support the overarm or related to in front of the base components. Table, it is the made up of cast iron mounted over the guideways machine on the saddle. The table provides z axis, the tool movement on the machining center. The tool changer, it is an automatic device used to change the tool from the machine spindle. And spindle, it is a rotary movement that is always z axis, so it is mounted on the headstock, also provide z axis movement. Servo system, this control system that consists of servo motor and feedback system. It enables accurate and rapid movement of x, y and z axis. Now these are the common for who this horizontal, also vertical. Now with respect to take the merits and demerits, that means advantage and disadvantage of horizontal machining center. So here observe that block diagram is showing here that axis or spindle movement is horizontal, position is horizontal, so that's why it is called as horizontal machining center. And with respect to longitudinal, that is x, then respective saddle table, that is a y, and vertical movement, that is a z axis. Now that fixture movable in rotary action, that is a clockwise and anti-clockwise direction. So merits, table index capability enables multiple side of workpiece to be machined in setting and clamping. Chips drop out the way during machining, provide an uncultured view of the cut and preventing recutting of chips. So operator station is the one side of the column, provide good line of sight control. Pallet shuttle exchange mechanisms are open, where that pallet mechanism is open and easily accessible. So it is also suitable for the large box heavy parts also. And some disadvantages, it is difficult to load and unload, it is a large workpieces. High thrust may be absorbed by this tombstone fixture or right angle braces. Heavy tool can deflect, generally more costly. So these are the disadvantage. Now similar vertical machining center, that block diagram to change only position of that spindle is vertical. So that is a vertical machining center. So under this longitudinal, that is the x direction. So that is front side, that is a y direction, and always vertical movement says the z direction. So merits of means advantages of VMC. The thrust is absorbed directly on the machine table because that movement is vertically. Ideal for large flat plate work and single surface 3-axis countering. Heavy loads can be used without concern about deflection. Generally less costly as compared to HMC. So disadvantage, the workpiece size is increases, it becomes more difficult to conventionally loop down because in horizontal that surface or flat surface is there, so it required for the large component, but in VMC that is for the small components. Extensive chip built up abstract view of the cut and recut chips are formed. On large vertical head weight and distance from the column can cause head drop, loss of accuracy and chatter. Chatter means that form as a some sketching like scratch, not suitable for large boxy heavy parts. So as compared to horizontal machining center. Now sometimes question may be there, specification of machining center. So now these are the common parameters for the HMC and VMC. So first, travel in X and Y and Z axis. So that travel under distance that is in form of mm. Then spindle center to work table in mm. Spindle nose to work table, that is also in mm. Table surface to floor, that is a area, not area, that is a measurement, that is a mm. Table size mm. T slot bolt specification and mm. Maximum weight on the table, that weight nothing but measure in kg. Table indexing in degree. Spindle, that should be taper. Spindle diameter and speed, so diameter always measure in mm. And rpm, speed measure in rpm. Then feed rate mm per revolution. ATC, automatic tool changers, so there may be capacity of that ATC, APC, automatic pallet changer. So there is again quantity of many pallets are provided for that machine. Then machine floor space, it is also in length into width, whatever area. Machine weight in kg. So these are the parameters of the machining center. Now axis identification in milling. So total 12 degree of freedom, already aware about that. So how that 12 degree of freedom said? So in XYZ axis for the 3D components, so that as coordinate point of view, plus and minus. So similarly forward direction, that is a positive, and backward direction consider as a negative. Similarly 6 axis xyz as plus, xyz as negative means 6, and for rotary axis ABC are used. So in clockwise one axis and anti-clockwise one axis. So similarly this 6, the total is 12 degree of freedom. So Z axis, first Z axis is fixed for machine tool. It is shown in the spindle axis. Always rotary motion of the spindle called as a Z axis. Movement of cutter in upward direction in positive Z axis. In downward there is a negative Z axis. In vertical machining center, Z axis is vertical. On horizontal machining center, Z axis is horizontal. So whatever rotary axis, that is called as a Z axis. X, it is always horizontal and parallel to the workpiece. Remember this. The longitudinal travel the work table. When looking from the tool spindle to the column and positive X direction is identified as being to the right on vertical milling machine. Now Y axis, it is always perpendicular to the both X and Z axis. It is also horizontal, indicate that cross travel of the table. So in longitudinal always X, and transverse, that is a cross, that is a Y, and height, so that is the Z axis. And Z may be vary, but it is always rotary axis of the spindle. Now axis identification in milling machine. So it is very simple way. Here we just observe in fourth quadrant system is there, that is a horizontal plane and one of the vertical plane. So here this is a horizontal plane, this is a vertical plane. Now from this origin, the right side, that is a positive x, this side negative x. Similarly y in the cross, that is behind this is a y, and in front this is a y negative. Similarly z in upward, so that is the z axis, and below the origin, that is the negative z axis. But now here this is a machine 0, a workpiece 0 position is here. So from this point, that moment indicate the positive z, and here that is a negative z. So this is a rotary axis, that's why it is called as a z. And x vertically, in upward direction positive and in downward negative. So here also block diagram I am given here, that spindle movement always z, and x workpiece movement, that is a y cross movement. So x y z to remember likewise. Now, thumb rule of axis identification. Most of the time that question is fixed for final exam point of view. The axis can be identified by using right hand thumb rule. So that's why this is called as a thumb rule of axis identification. Now here observe that the z axis is fixed as the main spindle, so that main spindle indicate the middle finger of right hand. So middle finger of right hand indicate the z axis, and the x axis is then identified horizontal and parallel to the workpiece. So that's why x axis is parallel to the workpiece, and y-axis is the indicated index finger of right hand. So that is index finger vertical way, that is a y. So positive direction of all three axes is along the outward direction of the fingers away from the pen. So negative direction of all three axes is along the fingers pointing towards the palm. So this consider as the origin is here. From the origin, these are the positive axis, and in the downward as towards the palm, this is the negative axis. So I hope students have understand this chapter, that is what exactly NC, CNC and DNC that distinguish. Then after that, classification of CNC, and then its basic components, where is the feedback devices, cross slides, recirculating ball, then cross slides, encoders, decoders, then analog and digital based classification, then open loop and closed loop. Then after that, essential component, then tool presetting, qualified tools, then after that machining center. So these are the contents related to the chapter. As per my knowledge, I hope you understand this. So question point of view, you have to remember that classification of NC, CNC and DNC. Then after that, classification, then each component try to draw figure and state its function. So that is the things are very important while you are doing the study. So I hope you have to understand very well. Thank you.